Okay, today we're going to do our Unit 6 notes number 2, it's called Factoring Out a GCF, or a Greatest Common Factor. So this we should be familiar with. It's also going to be like the inverse of division of our polynomials, so kind of what we just did. So by the end of the day, you will be able to factor out a GCF. And we'll also be able to check our work to make sure we factored out the right GCF. So to simplify the following. So for this, we should remember, we just have to distribute. So multiply your coefficients, add your exponents. So you get 6x cubed minus 3x squared plus 15x. Now, remember that this one we multiplied. Now to do the inverse, we would just divide. So remember each operation so whether it's addition, subtraction, multiplication, or division, has an inverse. So like your inverse of addition is subtraction and your inverse of multiplication is division. So factoring is just going to think, okay, what is the greatest coefficient I can divide out of each of my terms, and what is the biggest exponent, or what's the largest number of variables I can take out of each term? So whenever we're factoring, this is the inverse of multiplying our polynomials, which is also called dividing. So we're basically going from a whole polynomial to multiple polynomials. So we're going from one polynomial to multiple polynomials. Okay, so now let's get into it and how we factor out our GCF. So on the ones below, we're just going to identify the GCF. So what is the number that we can divide 14, 6, and 8 by? So let's go up. We can take 1 out of it. We can divide all of them by 1, but we're going to have a bigger one than that. Can we divide all of them by 2? Yes. 3. Only 6 can be divided by 3. 4. Only 8 can be divided by 4. And 14, the only two numbers that go into 14 are 2 and 7. So we have to think your biggest number you can divide all of these by would be 2. So the next one, we added a little bit more. We added coefficients and we added variables. So we are first going to look at, okay, what is a number I can take out of my coefficients? So what is the biggest number I can divide 4 and 16 by? That would be 4. Because you can do 4 divided by 4 and you can do 16 divided by 4. Now we're going to look at our variable, x. I have 3 x's here and 2 here, so the largest I can take out would be x squared, because you can't take 3 x's out of 2. And then lastly, you have your y's. You have 1 y and 2 y's, and so the max you could take out is going to be 1. So hopefully that gives us a little bit better understanding of what I mean by find the GCF. So let's go down to our explanation. So first we have to find the GCFs of the coefficients. So we look at our coefficients first. We have 15 and 10. So our GCF of our coefficients, what's a number that can go into both 15 and 10? That would be 5. Then we think, write out the variables and circle all the terms that have in common. So if I were to do that, on the first one I have 3 x's, and the second one I have 1 x's. So how many do they have? Hold on, the second one they have 1 x. So how many do they have in common? They just have 1 set of x's. So your GCF is going to be x. Then let's look at our y's. We have 4 y's. And we have 2 y's. So we have 2 sets in common. That means we're going to have y squared. So that is our GCF. So we're going to rewrite 5xy squared. Now I have to put the leftovers in parentheses. So you're basically dividing this out from every term. So what's 15 divided by 5? That would be 3. I took out 1x, and I have 3 x's, so I'll have 2 x's left. I had 4 y's. I took out 2, so I would have y to the second. Bring down my subtraction sign. 10 divided by 5 is 2. I had 1x, and I brought it out, so I have none left. I had 2 y's, and I brought them out, so I had none left. So then I closed my parentheses. Now, whenever you're done with this, you can double check your work. So how did I do this correctly? And you would just redistribute it through. So 5 times 3 is 15. X to the third, y to the fourth, because you add your exponents, minus 10. And then I would just add on the x and y squared. And did I come back to the same thing that I started with? Yes. So I did it correctly. So you will have to check your work on some. So keep in mind with that. Okay, let's go to the next page. So how can we check our work? We just did it, and we would distribute. So we will be having you check your work quite a bit, so keep that in mind. Okay, it says factor out a GCF. So the first one, I have x squared plus 2x. So is there a coefficient I can bring out besides 1? No, because that x squared doesn't have anything in front of it. So I have 2 x's and 1x. So the max I can bring out is an x. So then I'm going to divide everything by x. So I'll be dealing with an L1 with an x. And then I didn't bring out that 2, so it stays there. And then I brought out an x. That's all I'm left with. Now to check my work, I'm just going to distribute. So I'm going to get x squared plus 2x. And I did it correctly. Now the next one, look at our coefficients. What can we divide 3 and 9 by? We can take 3 out of both of them. So we're going to pull out a 3. Then we have v to the third and v to the second. So we have 3 v's and 2 v's. So there's only 2 pairs that match. Parentheses, pulled out the 3. I had 3 v's and I pulled out 2, so I have 1 left. 9 divided by 3 is 3. I had 2 v's, I pulled out 2, so I have no v's left. Then I would distribute. 3 times 1 is going to give you 3. And then you had 2 v's and then 1 on the inside, so you're going to get v to the third. 3 times 3 is 9. And then you didn't have any v's, but you had the v to the second on the outside, so you just add that on. And that is what I started with, so I'm good. Put this check mark out. There we go. Okay, going down to the next one. I have 7 and 7, so 7 can actually go into both of those. So I'm going to pull out the 7. I have 2 m's and 1 m, so the minimum the max I can pull out is 1. Then I have x and x to the third, and the maximum number of x's I can pull out is 1. So the number of variables you can pull out is always going to be your lowest exponent if there's 2 of them. So pulled out my 7 already. I had 2 m's. I pulled out 1, so I have 1 left. And then I had my 1x, and I pulled it out. Then I add, pulled out my m, had 3 x's, and I pulled out 1, so I have 2 x's left. So that would be what it looks like. That one's a little bit different. So then I'm going to distribute to check my work. 7 times 1 is going to give you 7. M and m is going to give you m squared. I'm just going to tack on my x. 7 times x squared is just going to give you 7. And then m. Then you had an x and 2 x's, so you're going to get x to the third. Is that what I started with? Yes. Okay, next problem. So on this one, I'm going to see coefficients. I have a 16 and a 4. I can pull out a 4 from both of those. I have 1x and 3 x's, so I can just pull out 1x, and then I have y and y squared, so I can just pull out a y. 16 divided by 4 is going to give me 4. I had an x, pulled one out. Had a y, pulled one out, so I don't have anything left on that one. 4 divided by 4 is 1, so you can put the 1, you don't have to. Had 3 x's, pulled one out, so I have x squared. Had 2 y's, pulled one out, so I only have 1 left. Distribute. 4 times 4 is 16. I just have an x and a y. And then 4 times 1 is going to be negative 4. X and x squared is going to give you x cubed. Y and y is going to give you y squared. Is that what I started with? Yes. So I solved it correctly. Okay, going down to the next one, it says solve the given quadratic. So on this problem, we're not simplifying, we're just solving. So we're finding our zeros. So whenever I say find my zeros, I'm going to set each part equal to 0. So I'm going to have 2 equals 0. I'm going to have x minus 4 equals 0. I'm going to have 2x minus 7 equals 0. And I'm going to solve each one of these. 2 doesn't equal 0, so that one's done. Add 4. You get x equals 4. Add 7. You get 2x equals 7. Divide by 2. You get x equals 7 halves. I'm not going to simplify that. So I have two solutions, 7 halves and 4. So I'm going to write that as a solution set. And you can look at this. I had 2 variables in there, so I'd have 2 solutions. Now the next one, it says solve. So our first step whenever we're solving is we want to factor it first. It'll make it a lot easier, factoring out our GCF. So I can pull out an x from both of those. So I'm going to have x minus 3 equals 0. So then I'm going to set each part equal to 0. So I'm going to have x equals 0, and I'm going to have x minus 3 equals 0. Add 3. You'd have x equals 3. So my two solutions are 0, 3. So you may ask, how did you know to factor out? Well, this one's already factored. I don't have an x squared. And this one, I have an x in both terms. So I know I need to get rid of an x so that I can make it a lot easier whenever I'm factoring that. Okay, let me know if you guys have any questions or notes, and you guys can get started on your homework.